right, we did have one student in here attempt the extra credit, was really close. Just a little bit of a sign issue there, but did a good job otherwise. Let's go and turn your textbooks down to page 72, and let's take a look at number 5 together. We're going to do a few more of these functions together, reviewing over what we started talking about yesterday, and then we'll move into the other part of the reading that you had a couple nights ago. Number 5, we're given a function of x is x squared, and it says find f of x plus h minus f of x all over h. And it looks positively ghastly. But really there's only 2 steps. First, find f of x plus h. Well, when I see f of x plus h, that means I need to plug what in for x, class?
X squared.
No, I need to plug what in for x? X plus h. If it's at f of 3, I'd plug in a 3. If it's at f of 7, I'd plug in a 7. If it's at f of m, I would plug in an m. It says f of x plus h. So class, I plug in x plus h. And when I plug in the x plus h, that means I have to square it. So the whole f of x plus h is simply going to, or is just going to become
X squared.
oh yeah, x plus h quantity squared, but let's expand it out.
X squared plus h squared. 2.
So square the first, square the last, multiply and double, plus 2hx, right? So I square the binomial, that's f of x plus h. The next part's actually really easy. It just says f of x. Well, what is f of x? X squared. So minus x squared all over h. And now we can just let algebra take over. So there's that initial step of the algebra of the function notation. And now we just roll with it. Now what do we do, anyone? Cancel the x squared, negative x squared.
Take out h.
Factor out an h to be left with
2x plus h.
and the reason we wanted to factor out the h is so that I can cancel the h. So we'd be left with 2x plus h, where the h that we canceled cannot equal 0. Remember, anytime you cancel a factor away, set it unequal to 0. Looked a little weird, but that's all there is to it. Does that make sense? Okay. Look at number 7 now. And this is very similar to the bonus problem that we had, or the extra credit problem we had last night on number 6. So at your seats, go and do that initial first step, and then we'll work through the algebra together. We'll copy down number 7, and then we'll work through the algebra together here. Given f of x is 2x cubed plus 6x squared plus 3x minus 1. We're finding f of y minus 1. Again, the initial step is just plug it in for the x. And if this were a numeric value, we'd try to do a lot of work in our head. But it's not just a numeric value. So our first step really should just be plugging it in. What should it look like when I do, Chris?
6 times y minus, or 2 times y minus 1 cubed plus 6 times y minus 1 squared plus 3y minus 3 minus 1.
Good, he went ahead and distributed the 3 in advance, no problem with that. I'm going to leave it like that plug-in step for now, though it's going to be easy to do here in a moment. And then we come to this. Now, I've got a 2 that I need to distribute, but I've also got an exponent. Which one comes first, class?
Exponent.
Exponent. So I can't distribute the 2 until I cube the binomial. I also cannot distribute the 6 until I square the binomial. But there's nothing to stop me from distributing the 3, which Chris already did when he got the 3y negative 3. And the negative 1 back here doesn't need to have anything done with it.
Take it on, just make it 3y minus 2.
Minus 4, careful, right signs are the same. We'll get to that in a second. What do we get when we square the binomial here? Ethan?
Alright, so square the first, square the last, multiply double.
Yeah, good. Square the first, square the last, multiply double, you said.
So y squared, and then 1 at the end, and then negative 2y.
Good. 1y doubled is 2y. And then we come to this binomial cubed. And we need to go back in your mind to Algebra 2 at the end of the school year. And we talked about a way to quickly raise any binomial to any power. And there was a poster that we had up on the wall with a whole bunch of numbers that kind of made this pattern. Anybody remember what that thing was called?
Pascal's temple.
Not Pascal's temple.
Triangle.
Pascal's triangle. And remember, Pascal's triangle started at the top with a 1, and then it went to 2 1s, and then we had ones on the outside and more ones on the outside, but in the middle, I would add these two digits cause to get a 2. And then add these two digits to get a, and these two digits to get a 3. And I put ones on the ends and I'd add these two to get a 4, 6, 4. What would the next row be here, Jamie?
1, 5, 10, 10, 5, 1.
How about the next line, Chris?
1, 6, 15, 15,
Careful.
20, 15, 6, 1.
Good, and there's this symmetry too. And of course, we could keep going. I think some of you did. You made a whole bunch of rows to Pascal's triangle when we talked about this. Well, we don't need a bunch of rows because we're only trying to cube. Which row do we want to focus on here, Quentin?
1, 3, 1.
Good, the 1, 3, 3, 1 row, because the row that has the 3 in it is your cube row. And so what I'm going to do here is I'm going to start with, by writing my coefficients, 1, 3, 3, 1. And remember, we're going to take that first value and we're going to start it out cubed. So y cubed, class, and then the y is gone. The 1 is going to start out gone, then y to the first, which is 1, then the 1 is squared, which is 1, and then the 1 is cubed, which is 1, which, again, anytime you multiply by 1, it doesn't matter, right? But if it were any other number, I'd be writing those numbers in. And then if there was a negative here, my signs would have to alternate. Positive, negative, positive, negative. Make sure you're doing this along with me there. All right, do we remember this now? Now, Chris, what you're remembering is we did division by inspection in Algebra 2, and also, because you didn't do the last quarter material because we had to do it at a weird time, weird stuff happened. COVID and all. But there's also, factoring the sum or difference of same odd powers.
That's what it is.
Was the same thing where it was the descend the one, ascend the other, and then put in the signs. So very similar concept. Again, math is all about patterns, and that's a pattern that comes up a few times. From here, y'all should be able to finish it out, so at your seats, do so. I think I love about pre-calculus, it ends up reviewing just about every algebra concept at some point during the year. Which is good coming off geometry, right? Need that review of algebra. So we didn't do that much algebra last year.
There's not very much canceling you can do.
No, not really much, right? We've got the y squares will cancel, but I think that's about it. Otherwise, we're going to have to actually finish this out.
Well, you can also,
So the 2y cubed has no friends, right? We're going to keep that. We've got a 6y, a 3y, and then a negative 12y.
negative 9.
Negative 3y.
Negative 3y, because you end up adding to get a positive 9y. Then put that there to get the negative 3y. And then my regular numbers, I've got a negative 2, negative 3, negative 1.
Or negative 6.
Oh, and so together, collectively, they cancel with a positive 6.
That's what I was trying to say.
And so there's my answer right there. All right, questions on this?
I didn't get that.
A bit ghastly, but here's the thing. If you're nice to the math teacher, I don't put problems like this on the exam. See how that works?
I actually did get this.
Yeah.
I had my answer I had was 2y cubed minus 6y plus 3y. I did. Would that be completely? That would be wrong on the exam technically.
You said plus?
I had 2y cubed minus 6y plus 3y.
So you just didn't finish the combination?
Yeah.
So minus a point. Okay. All right. Take a look at number 8. And we looked at a couple of these yesterday where we've got two variables in the function f of x, y. And we've got x squared plus y squared minus 2x plus 4y plus 7. And finding f of 2, 3 at your seats. Finding f of 2, 3.
There's nothing to cancel here. Wait, how did you? Oh, it kicks the x's and y's out.
Right, there's no x's or y's. 2 replaces the x and 3 replaces
Okay,
the y, remember?
Yeah, my bad.
All right, did we get to 28?
Mhm.
All right, and Chris, you see it now? Questions?
Yeah, no, I didn't want to make sure I didn't copy anything.
All right. Now the next part of this problem is just is annoying. F of x, x minus 1. Now only half of it's actually annoying though, because everywhere I see an x class, I'm going to have to put x. So in other words, I don't have to do a thing with the x squared, nor a thing with the negative 2x. And we never have to do anything with the constant, right? It's just where I see y, I'm going to have to replace it with x minus 1. So right here, I'm going to end up getting an x minus 1 squared. And of course here, a 4 times an x minus 1. Make sense? At your seats, finish it out. Getting strange looks. Did I mess something up?
That's right.
Questions, comments?
How did the second 2x become positive?
Yeah, that's what.
Oh, I just copied it wrong. Okay. All right, my bad. So this is a negative 2x. And for some reason, I copied a positive right there. So it's a negative 2x. So these negative 2's is negative 4, so the 4x is gone.
Yep.
How's that? Is that better?
Yeah.
Okay, I was like, I'm getting weird looks from everybody. That's usually not a good sign. It usually means I messed something up. I just copied it wrong. Questions on this? All right, evidently I am not perfect. All right, the next one is singularly obnoxious. F of x plus 1, y minus
I think
1.
they designed these to torture us.
I think they wanted you to get a really good algebra review in this lesson. So at your seats, go ahead and work that one now.
Oh my goodness.
Oh
You missed algebra class last year. Here it is, algebra 3.
I kind of did miss it though.
Algebra 3?
Yeah. Algebra 3.
Why not? So when Chloe was, I don't know, 2 years old, so it's probably 4 or 5 years ago, I'd come home from work and, my wife would ask, so how was your day? And, my day, like every hour is different, right? So I can't just say my day was good it was kind of like, okay, well this hour, thus and such happened, and this hour, this was kind of the main thing. So well, algebra 1 went well, pre-calculus went well, algebra 2, such and such happened, and so forth. Well, anyway, one day, so how was your day, Chloe? Well, algebra 1 was good, and algebra 2 was good, and algebra 3 was good, and algebra 4 was good. She didn't even know what she was talking, she was just mimicking Daddy. But anyway, I thought it was funny. Algebra, whatever. I think she was trolling me.
I hate this problem. There's not a single thing to cancel, is there? Oh, yeah.
Getting nods, that's a good sign.
Didn't forget a sign this time.
Yeah. Alright. Don't want to spend too much more time. Your questions on this? You ready to get back to pre-calculus and get away from algebra again, or you like the algebra?
I like algebra.
You're like, hey, actually, I'm cool with this. I can do this. All right, let's drop down to number 9, and this is a fun one. We've got f of x is x squared plus x. We're also given that g of yz is y cubed minus z cubed. They want us to find f of 3 times g of 1 negative 2. Well, obviously, the first thing we ought to find, class, is f of 3. What is f of 3?
3x squared, or no, 9.
9.
Yeah.
Oh, excuse me,
12.
12. 3 squared is 9, plus
Oh,
3
sure.
more is 12. So we're going to end up getting a 12 here. And then we need to find g of 1 negative 2. Well, what is g of 1 negative 2?
1,
Y cubed minus.
negative 7.
Or y cubed plus 2z cubed.
Well, 1 cubed, which is 1, minus negative 2 cubed, which is negative 2 cubed. Odd power keeps the sign. Negative 8. So it's 1 minus negative 8.
Negative 7.
1 minus
Nine.
negative 8. Remember, add the inverse. It gives us 9. So it's really 12 times 9, which is 108 is our answer there. Look at the next part. They want us to find f of g of negative 1, negative 2. Or maybe 2, negative 1. I'm dyslexic. Negative 2, negative 1. All right, add your seats. Find f of g of negative 2, negative 1. When I was in high school, my dad told me that the universal answer to anything and everything is 42. Apparently, he wasn't wrong. The answer is 42. How many got 42 for the answer here? Ooh, only Jamie. Okay, so let's take a look at this together here. We need f of something, right? It's going to be g of negative 2, negative 1. Cube the negative 2. Negative 8. Minus cube the negative 1. But we add the inverse, so we get negative 7. Then we're going to have to square that. 49 plus negative 7 is 42. Dad, you were right. 42 is the universal answer to anything and everything. It really is. All right, so here's another fun one. G of 3, f of 2. G of 3, f of 2. You got this. Take a minute, think about it. You'll get it. All right, at your seats.
Is 3 to the third power 27?
3 cubed. What do we get for f of 2?
6.
6. So really it's just g of 3, 6. Someone with a calculator confirm my math.
Yeah, I got it.
All right, see, questions on this. All right, let's take a look at number 10. And we've got f of x is equal to the tangent of x. I may have saw one of these yesterday with a trigonometric function in it. Let's blend a little algebra and trig here. Not bad, right? X just gives you the angle. And they can give it to you in degrees or radians. It appears they give it to us all in degrees here, though. They say find f of 0 degrees. Well, remember, where is the tangent line on the line diagram? Which one is the tangent?
Go one to the right.
It's the one on the outside.
On the outside going straight up and down, right? This is my tangent line. So if I have a 0 degree angle, what's the tangent line?
0.
0. So f of 0 degrees is 0. What about f of, they say 30 degrees. What if they said f of pi over 6? Same thing, right? 30 degrees. So now remember, that's a half. It's a little bigger than the half.
Square root of 3 over 3.
Square root of 3 over 3. They say, what is f of 90 degrees? Again, it could have said pi over 2, so at a 90 degree angle, what's the tangent line?
Undefined.
Undefined. What about f of 180 degrees? Well, here's your 180 degree angle. How big is the tangent line?
0.
0. And then they say, ooh, f of the arc cosine of -1. What is arc cosine? What is any inverse function going to give you always? Some kind of angle, right? So the question when you see the arc cosine of -1 is this: when is cosine -1? Well, which line is the cosine line? In this triangle, it's this guy right here, right? What angle would give me a 1 for the cosine line?
A 0 degree.
A 0 degree angle. But what angle would give me a -1? 180. So apparently, the arc cosine of -1 is 180. But you could do that on the calculator as well. On your calculator, put in the -1 and take the arc cosine, or Ethan's case, the other way around, right? And you do get 180. So this becomes f of 180 degrees, which we just saw class was 0. And there's our answer. All right, questions on how we could even do functions involving trig ratios. All right, let's go and move on then. Flip back, if you would, to page 71. And something else that we talked about when we were in algebra class, I think even going back to algebra 1, this idea of inequalities, right? Inequality notation. And there's a couple different ways that things could be written. For instance, if we had between 0 and pi, right, the inequality notation would be 0 is less than or equal to theta, which is less than or equal to pi. We see that there in that little yellow box. But there's an easier way that I taught you in Algebra 2 to write it, and if it's an or equal to scenario, where here's 0, here's pi, it would be closed dot on the 0, closed dot on the pi, you'd shade everything in between. That's 0 less than or equal to theta less than or equal to pi. But I said another way we could say it, if it's a closed end, put a bracket and put the number. If this is also closed, another bracket, put the number and just separate them with a comma. How many remember interval notation?
It's algebra 2, wasn't it?
It's algebra 2, we did cover this. Look at the next one. What if it were negative infinity? Negative infinity is less than or equal to x is less than or equal, or is less than rather, x is less than 8. Well, again, on this particular one, here's your 8, for instance, but negative infinity, just circle, remember, goes all the way down to infinity. Well, another way to say it is simply x is less than 8, right? Going down to negative infinity is kind of implied. So you might have also seen it just x is less than 8. Either of these means the same thing, right? But to write it with the interval, we said if you don't actually hit the value, we would put not a bracket, but a parenthesis. Same thing on the 8. It doesn't actually include the 8. It's up to the 8, so we put another parenthesis. List the lowest value, highest value. Now in this case, say, well, what is the lowest value? Since it's not there, it's negative infinity. And that's a bad infinity symbol. And just put a comma between them. Do we remember this? Look at the next example. Negative infinity is less than x is less than or equal to 8. Notice the bracket on the 8, but still a parenthesis on infinity. You can never really get there. Negative 5 to 5. Less than or equal, y is greater than or equal to the negative 5, but less than the 5. Well, since you got the or equal to on the negative 5, bracket. Since you don't have anything on the 5, parenthesis. And of course, we have another one of those there. We got the negative infinity to 2, an unbounded interval there. So let me give you these then. What if I just said x is bigger than 2? If I were to graph this on the number line, I would start by putting a circle or dot. A circle at 2. X is all the points. So just 2, right? At 2, we put a circle. And x is everything bigger than 2. So which direction should the line go?
Right.
How far?
Infinity.
All the way to infinity. So we could say this goes from 2 up to infinity, right? And I would put a
Comma.
comma between them, since the 2 is not included,
Parentheses.
and since I never can include infinity because I can never get there, also a parenthesis. Is coming back to us? How about this one? X is less than or equal to 5. Well, again, on my number line, I'd start by putting a
Closed circle on the guard.
closed circle, or a dot, I call it, on the 5. And since X is everything
Greater
Less
than.
than.
less than or equal to, I'm going to go
Negative infinity.
all the way down to the left-hand side, all the smaller numbers, right down to negative infinity. So my lower end is,
Parentheses.
you just said it, negative infinity. My upper end is
5.
5. And you just list the ends. But since you can never really hit negative infinity, you put a,
Parentheses.
but you do include the 5, right? We've got the or equal to, we've got the closed dot, so.
Bracket.
Now if you're looking in your textbook, this is an older textbook, so they're using the older method of on the number line actually putting parentheses and brackets. They've changed over the years to go with open dots and closed dots, right? Open circles and closed dots. So a little bit dated there. New edition's coming out soon, but anyway, I don't think
When
it's.
does the new book come out, do you know?
I don't know. Probably the
Doesn't
next
matter,
couple of
we
years
won't
it should be
have to
soon.
use it.
You won't have to use it anyway. But know the circle and dot method, not the bracket and parenthesis method on the number line. Intervals still use brackets and parentheses. Though if you see it maybe in an older math text, you'll know what that means. How about this one? 3 is less than x is less than or equal to 7. How would I write that as an interval? Ethan?
No, we do our line, right?
We could do our line, but maybe you can picture the line and skip actually drawing it because we're too lazy.
Okay, so, parentheses 3, comma, 7, bracket.
There we go, because we know we have a circle at the 3 and a closed dot at the 7. What if we had a negative 2 is less than x is less than 0? Chris?
You would have closed, or you would have negative 2, comma, 0, bracket on the negative 2, bracket on 0.
Because they're both included?
Yes.
Not without the or equal to. With the
So
or
it
equal
means parentheses.
Right, if it doesn't have the or equal to, it's not actually including. It's like right up until you get to negative 2. It's like negative 1.999 is okay, but not negative 2. And then negative 0.00001 is okay, but not actually 0. So we'll put the parentheses on those. Does this make sense now? Well, if I saw this, I should be able to go the other way as well, right? I know that negative 2 and 0 are the ends. I know I don't use or equal to's, and x is in the middle, right? So I should be able to go both ways. Page 72 in your textbooks. Page 72 in your textbooks. So I want you to do 11 through 13. So flipping back across, or back a page 72 again. 11, 12, 13. If you need to draw the number line, that's quite all right. Faster without it, but hardly a sin to use it.
You just want us to start the bracket stuff, right?
All right, so number 11, what did you put for your interval, Quentin?
Bracket negative 6, comma 0, bracket.
Good, bracket, negative 6 comma 0, bracket. Number 12, what did you put, Jamie?
Parentheses 3, comma 7.5, parentheses.
Good, 3 comma 7.5, parentheses all around the outside. And number 13, Chris.
I had brackets 1, comma, infinity bracket.
Can we ever reach infinity?
No, it would be a parenthesis.
Parenthesis on the infinity, but bracket 1 comma infinity, and then the parenthesis at the end. Anyone got all 3 correct? All right, by the way, what if it had said this? Then what?
Parentheses negative infinity.
Same thing, because x is still bigger than the 1. And it's kind of written in reverse. They were kind enough to put 1 is less than the x, and we normally want the mouths opening this way. Small or getting bigger. If you see one reversed, pay attention to that. Does that make sense? All right, so numbers 14, 15, and 16, they want us to write each of these as an inequality. I want to start by graphing them though. So at your seats, go ahead and graph numbers 14, 15, 16. Just draw a quick sketch number line. Doesn't have to have a whole lot of extra detail on it, just the bare minimum. Arrows at the ends, make sure the zero's on there, and then the 2 key points, if you even have 2 key points. And then dots and circles as needed. Just a lot of review today, which I guess right before exams is kind of nice.
So there's no new lesson today besides this?
Well, there's more coming, but everything we're doing is something you've learned before.
So now that we've done trigonomics,
We're not done with it. We got plenty of trig still to come.
how much trig is throughout the year? Like how much of it is trig?
Up until about the end of January. And then we change gears.
To what?
Analytic geometry, the other thing on the cover.
No proofs.
No proofs though, no proofs.
No, it's just parabolas and hyperboles
And whatnot.
and hyperbolas.
Hyperboles and parabolas.
Hyperboles.
Hyperbole is like when you go home and say, this is so hard. Hyperbole.
It is pretty hard.
All right, number 14, when you graph it, you got your number line with the arrows at the ends, you got your 0. Negative 1.5 would be right about here. Open dot or open circle or closed dot? Open circle at the negative 1.5, and then 1, 2, 3, 4, 5. Right in between the 4 and 5, circle or dot? Circle again at the 4.5, and then we're just going to shade everything in between. How would I write this as an interval then?
Negative 1.5 is less than x, less than 4.5.
There we go. We just basically put x in the middle, and we use less than symbols to progressively get bigger. What about the next one? We've got negative infinity up to the 5. Obviously, I can't put anything at negative infinity, but I can at 5, class, put a closed dot. So 1, 2, 3, 4, 5. Put the closed dot there, and we're going to shade
Everything to the left of 5.
everything to the left. Everything to the small side, all the way down, including the arrowhead, remember. Okay, make sure we even shade the arrowhead. And so if I were to write this as an interval, I could say negative infinity, less than x, less than or equal to 5. But if it goes down to negative infinity, I could also just say that. Okay? Questions on this one? Do we have it graphed correctly? Looking at the last one, 8 to 10, this one should be pretty straightforward. We have an 8, we have a 10. On 8, we put a closed dot. On 10, we put a closed dot. We shade everything in between. How would I write this as an interval, Jamie?
I have a is less than or equal to x is less than or equal to 6.
There we go. Again, the main thing I'm going to want from you, though, is the interval notation. I don't want the greater thans and less thans. I like parentheses and brackets, and that's what we're going to be using as we progress through. Next section, your notes, domain and range. Next section, your notes, domain and range. And there's a collective groan that goes up from the crowd as they remember learning these back in Algebra 2. And this was apparently not one of your favorite things to have to learn. But it's an important thing to learn, domain and range. Domain, first of all, let's talk about that. Domain refers to all possible x values that may be entered or plugged in, you might say, into a function. So 2 key words to take along with domain. These are x's. They're ones that are entered in. They're ones you put into the function. Range, by contrast, is all the possible, and we used to say y values. I suppose we could, but in function notation, we don't use y, we use f of x. So all possible f of x values that may be obtained. Or gotten from, if your vocabulary is not as good. All possible f of x values that may be gotten from a function or obtained from a function. So domain refers to what you're allowed to plug in. Range is what you can get out. If you want to even write that off to the side, it's more writing and I'm lazy, so I won't. But if you want to, domain, what you're allowed to plug in. Range, what you're able to get out. Okay, so for instance, if I gave you this function, f of x, and I'd write this in the notes, is equal to x squared. And I want to say, what is the domain of f of x? Well, the domain of f of x, what am I allowed to plug in for x? And rather than thinking, what numbers can I plug in? Well, I can plug in a 2 and a 7 and a negative 13 halves and a 4.987. Rather than thinking that, start with, well, is there anything I can't? What can't I plug in for x?
0.
I can plug in a 0, 0 squared, 0.
There's nothing you can't plug in.
There's nothing I can't plug in. I can plug in anything. So the domain here is from negative infinity to positive infinity. Or, a faster way, and I think I showed you this symbol back in Algebra 2, all real numbers. It's an R with a double stick. Okay? All real numbers. You can plug anything you want into this function. All right, let's talk about the range. The range of f of x. What am I able to get out? So then you have to think, well, what kind of values do you get when you square?
Positive.
Only positives. Is there a limit to the kinds of positives? Can I get decimals? Yeah. Can I get fractions? Yeah. Can I get really big numbers?
Yeah.
Oh yeah. Can I get really small positives? In fact, I could even get 0. If I square to 0, but anything else is going to come out to something positive. So here my range goes from 0 to infinity, including the 0, but not, of course, including infinity. Do you see how to think through domain and range? Domain, what am I allowed to plug in? And oftentimes you kind of start by assuming you can plug in anything, unless you can think of, well, I guess I can't plug that in. Okay? And then for the range, what do I get out of this thing? What kind of numbers do I get from this? How about this one? F of x is equal to x cubed minus 2. F of x is equal to x cubed minus 2. Let's talk first about the domain and then the range. The domain class refers to all the
numbers you can plug.
all the x values that I'm allowed to plug in. What am I allowed to plug in? Or better question, is there something I'm not allowed to plug in?
No.
I can plug in anything, right?
All real numbers.
There's nothing I can't plug in, so I guess the domain is all real numbers. All right, then we switch to the range. Okay, is there anything I can't get out, or what kind of numbers do I get? Well, when you cube something, what kind of numbers do you get?
Positive or negative.
Positives or negatives, right? And if I subtract 2 from a really big positive, what do I get? Still a really big positive, it's just 2 less, right? Even infinity. If you subtract 2 from infinity, you're still at infinity because you're 2 less than infinity, but then that is a mind-blowing concept, right? And then if you plug in a really big negative and then you cube it, it's going to be even more negative-y negative, and you subtract 2 more, it pushes you even that much further. So the range is going to be all real numbers.
These are the kind of questions that I like what happens if you take 2 from infinity? Would you still be at infinity, or would you still be at would you be at 1 octillion, nonillion?
I don't know, it's mind-blowing because we just can't
Those
wrap
are
our
the
brains
kind of things I
around.
like.
Yeah, things that make no sense, right?
Exactly like Ethan's speech.
All right.
Chris's
All right. So what about this one? F of x is equal to the square root of x negative 3. For the domain, again, domain is everything I'm allowed to plug in. Is there anything I can't plug in?
No.
Remember, can you take the square root of a negative?
No, so 0.
No. So 0, I can't plug in a 0 because that would give me a negative 3. What else?
Yeah, plug in a 1, 2, or a 3.
I can't plug in a 1 or a 2, but I could plug in a 3, couldn't I? Because that would give me a 0. I can take the square root of 0. That's 0. But so I've got to plug in at least a 3, right? Anything bigger than that, I'm good. What about a negative number?
No.
No, because that would be really negative. So as long as I plug in at least a 3 from 3 to infinity, I'm okay. Does that make sense? All right, what kind of values will I get out? Well, if I put the square root sign somewhere, I have to also put positive, negative, right? But this square root symbol was already there, and what sign is in front of the square root? An understood positive. So what kind of numbers are going to be spit out by this radical?
Positive.
Only the positive roots. So therefore, my range is only going to be
Positive infinity.
So 0 to infinity.
0 up to infinity. I can plug in from 3 to infinity, and I can get out from 0 to infinity.
I have the answer right, I'll take that.
All right, questions on this? All right, for homework tonight, you'll be practicing with a handout. If you're watching on YouTube, of course, as always, it's in the description of the video. And students in here, you have the handout here.
Thank you.
And we'll take a look at that handout in our next lesson. Have a wonderful rest of your day.